Hey, and welcome back. How y'all doing today? This is Mr. Cole here. Let's go through and let's try and work now a basic series resistor problem. Now remember, what is it makes a series resistor or a series problem a series problem? Remember, what's going to happen? The current is going to leave this battery and it's going to flow through. So the current would come to this resistor, it would come in and through and out and all the way across here. Sorry for my random tablet picking up a mark. Anyway, and would continue through this. So one of the fundamental parts of this circuit is remembering that your current, your total amps that you find in this circuit, it's the same, if you remember, all the way through the circuit. So all of the current, because remember, you have to have a junction, you have to have a branch. If you've forgotten what that means, to basically to be a parallel circuit, there needs to be something like that in there. There needs to be a place that this electricity can actually split, the flow can split. So there's our foundation. So let's do something. Let's add some numbers to this problem. Let's just go with a 3-volt potential over here at the beginning. And let's give our values of resistance. Let's get some values for these resistors. So let's say resistor 1, let's make these rather kind of on the easy side. Let's make this one 20 ohms of resistance, 40 ohms, and let's go with, I don't know, 60 ohms. A good question right off the bat for a problem to ask would be, which one of these has the least amount of current in it? And of course, it's a trick question. We've already talked about it. These are in a series, so your resistance would be, if you said the same, you are correct all the way across. Now, another problem might say, which one of these, and we wouldn't have to even solve this problem, which one of these would have the greatest potential across it? Well, the greatest potential would be resistor R3. It's the greatest resistance, so the bulk of our potential, our 3 volts, is going to be used up getting the electricity, getting the current to actually push through that resistor. All right, so now that we've kind of looked at this a little bit, how do you go about solving these problems? And whether there were just 2 problems in R1 and R2 or 20 resistors, the foundation behind it is the same. So I'm going to give you like a little set of instructions here. The first thing I'm going to say that you need to do is you need to go through and establish what your total resistance is. Now, since this is a series circuit, that's very easy. All you're going to do is add up all your resistances. So in this case, it would be 20 ohms plus 40 ohms plus 60 ohms. And so that adds up to 120 ohms of resistance. And I'm always going to tell you, even if you had like this crazy, insane looking question with a bunch of resistors, your first priority should always be trying to find what this total resistance is. Again, the only thing you'll see, some textbooks will use the equivalent resistance. So they'll use like this little REQ notation. It really doesn't matter. Some books will also just go RT for our total. So just so you know the different notation. All right. Now I'm going to tell you this. The second thing for me, my goal is always to find like the total current in the circuit. Now, this is what's cool. The only formula we will use to solve the rest of this problem is Ohm's law. So for the rest of this problem, V equals IR is the only thing we're going to need to solve every other answer in this problem. Because here's the thing. If I want to know the current total, what was the voltage total in this circuit? Well, we go all the way back to the beginning and we look at the potential in this. We only have 3-volt potential. So we had a 3-volt potential in a circuit with 120 total ohms of resistance. So by taking this 3 divided by my little My screen disappeared there. Let's see if that works. So 3 divided by 120 is a 40th. That's always handy to know. So 0.025 amps. So our current in this problem is 25 milliamps. So 0.025 amps. So that means that leaving this battery now is what? Leaving this potential, this power source, there is 0.025 amps of electricity leaving the battery. Well, so now what's the question? How many amps are flowing through R1? 0.025 amps. So now, trick question. How many amps are flowing through R2? Oh, well, that's kind of great. 0.025 amps again. So we're still in bank. And then, so how many amps are flowing through R3? Well, 0.025 amps. So now, the only other question, in other words, we've now identified I1. We know what I2 is. We know what I3 is. The only question that could potentially be left for us to find would be this. What is the potential, we'll call it V1, what is the potential across resistor R1? What is the potential across R2? What is the potential across V3? Now, we know the total potential in the circuit. We already know that the total potential, we've already established it. It was 3 volts. It was one of our givens in this problem. So we're able to kind of, we know this much. So how can we go and find V1, V2, and V3? Remember what we said at the beginning. The only formula we will use after finding total resistance is this R total, or this Ohm's law equation. So it really boils down to this. Let's say, for example, you want to find the voltage across resistor 1. Then you need the current in resistor 1, and you need the value of resistor 1. Well, we already know that the current going through resistor 1 was 0.025 amps. And we know that resistor 1 was what? A 20 ohm resistor. So we've got our current, and we've got our resistor. So 0.025 times, don't know why I'm doing this in the calculator, 1/2 of an amp, or 1/2 of a volt potential, So now I can get my thing to work again. 0.5 volts of potential are across the first one. So we know what that value is. So now then the question would be, well, what's the potential across number 2? And you should have some pretty good intuition in this. So resistor 2, we should be able to do this without even working it. On the second resistor, it had twice the resistance. So if it's got twice the resistance across it, what do you imagine would be true about the potential required to get it through there? Well, I mean, we could solve it. It'd be 0.025 amps times 40 ohms. But you should know that, or have the intuition that if it's double the resistance, then it's going to take double the potential in order to get through there. Now, this should also leave you, all right? So what's the potential being used across the third one? So what is the potential being used across the third one? Well, again, we could do the math. We know what the current is, 0.025. But we could also take advantage of our faculties among us here to also sit here and think about something. So check it out. If you've used 1.5 volts up of your 3 volts potential, remember at the beginning of the problem, we had 3 volts total potential, and there's 1 volt being used across the first one, and a 0.5 volt being used across the second one, how many volts would be left in the circuit? Well, it has to be 1.5 volts. And so there is our potential across the last one. Now, there is one other question that could be asked, and we didn't discuss it, But sometimes a problem will ask you for the power across the resistor. Well, power is just equal to IV. If you want to do some substituting using Ohm's law, it would be, let's see, V is IR, so you could do with I square R. Or you could even go V square over R. Again, all I've done is we know that V is equal to IR, so you can just substitute if you want to derive these other equations. But if you want to calculate, let's say your power across the very first one, what would be the power across the first resistor? Well, how much power is being lost over that resistor? Well, let's see, we had amps of what? 0.025 amps times we had a potential of 0.5 volts. So all we have to do is what's half of 0.25? So that would be 0.0125 watts, and there would be our power. Sometimes they'll look at this question, they'll ask you something like that. They'll ask you, it might even ask you, go back to beginning, and there's no sense working it out. It'll ask you which resistor, rank the resistors in order of which one has the greatest power being used from greatest to least. Well, obviously, the 60 ohm resistor is also going to have the greatest power consumption, and then the 40, and then the 60. So that's something you'll see a lot of times in these problems. But anyway, if you can do this series problem, you should be completely ready to go with all of them. So anyway, do